take more antiderivatives. The rest of the unit is all antiderivatives, but things get a little trickier. Okay? So, in today's lesson, we'll do a lot of things where you're going to make mistakes, but it's important to make those mistakes so that you know like why you made the mistake, why it's wrong. Okay? You have to do it wrong a couple times so that you don't do it wrong in the future. All right. Before we're doing this one, there's no trick here. Please take the antiderivative of this like you would normally take the antiderivative of that, like you did it on your quiz if you saw it today. No trick on this one. Okay, we use the power rule. We rewrite it as x to the negative second. To use the power rule, we then add 1 multiplied by the reciprocal. We get x to the negative first times negative 1 plus a c. So I get negative 1 over x plus c. Good? Okay, I need everybody using the same process / procedure. I need everybody to try to take the antiderivative of 1 over x. Rewrite it, power rule it, go for it. I need you all to have this experience. I need you all to have this experience. It's an important experience to have. All right, ready? We rewrite it as x to the negative first. You add 1, and you get x to the 0. You're not sure what to do with the reciprocal. Some people didn't write anything. Some people just left it as x to 0, and then they're like, oh, that's easy, x to 0 is 1. So the answer must be 1 plus c. But guys, what's great about antiderivatives is you can check your answers. You can take the derivative, and when you take the derivative, you should go back to where you started. If I took the derivative of negative 1 over x, I would get 1 over x squared. If I take the derivative of 1 plus c, do I get 1 over x? No. So we know this can't be right. And like, if you thought about a coefficient, maybe you thought about like a 1 over 0, and then you're like, well, now it's really confusing. So what are we getting from this? And this is the like super important rule with antiderivatives, is that the power rule works for every single power. Negative powers, fractional powers, works, except for negative 1. Power rule doesn't work. Okay, write that down somewhere, or just like commit it to your brain. Power rule works for every power. This is like every negative power. Negative 2, negative 3, negative 4, negative a half, negative third. Every positive power except negative 1. We don't use the power rule for a negative first power. So what do? Well, we remember what the derivative of the natural log function was. What's the derivative of log x? Oh, it's 1 over x, which means the antiderivative of 1 over x, which is also the antiderivative of x to the negative first, is log x plus c. Kind of. like 98% there. Remind your neighbors about the log function, like what's the log of e squared? What's log of e squared? You guys remember what log e squared was? Good. What was the log of e? Cool. Logs and e's undo each other, right? Because it's like e to the x equals e squared. If you take the log of both sides, the log of e, you get x equals log e squared. So it's like 2. That's got to be 2. So anyways, logs and e's undo each other. And then I could ask you, what's the log of 1? And you all should know that the natural log of 1 is 0. And then I ask you, what's the natural log of 0? No. Or I could ask you, what's the natural log of -1? Come on, guys. What's the natural log of 0 and the natural log of -1? Well, you're not sure, right? It's a question mark. Well, let's take e to the power of both sides and figure it out. If I take e to the power of both sides, I get 0 equals e to some number. What number can you take e to get 0? Not 0, right? Because the other 0 is 1. Okay, well, we're kind of stuck on that one, so maybe we go over here. Let's take e to the power of both sides on this one. -1 equals e to what number? No. That's what I'm asking you, what the natural log of -1. You're kind of going in a circle there, Murdoch. You tell me that's the answer. You can't do it, right? There's no answer. A number to a power is always positive. Remember when we talked about e to the x always being positive? When we were like analyzing e to the x and it's like graphs and we did some function analysis. You can't do this. This is undefined. This is undefined. Which means when you took the derivative of log x and you got 1 over x, and you use this is the tangent slopes of log x, you're only plugging in positive x's. Okay? So I'd only be plugging in positive x's in here. However, 1 over x, if we start with this, you could plug in any value you want, so long as you don't plug in 0. Which means I want to plug in any value I want into this log function, including negatives. So the one thing we have to change, the one thing that makes this like kind of right, is that we need an absolute value. We need an absolute value so that you could plug in negatives. Okay, so now I could ask you, what's the natural log of the absolute value of -1? Zero, because it becomes the natural log of +1, which is 0, so this is 0. I could ask you, what's the natural log of the absolute value of -e squared? Tell your neighbors what you think that is. What's the natural log of the absolute value of -e squared? Some of you will be wrong, and that's okay. So it's just 2. Why? It's like you're taking the natural log of the absolute value of -e squared. Let's work our way in and out. You would take the absolute value of -e squared, it becomes +e squared. That's what absolute values does. It takes negatives and makes them positive. Now we'll take the log of e squared and get 2. Okay? So that's why we have the absolute value, so that I can plug in negatives into the antiderivative. Okay, cool. Well, we've just been talking about some e's. Well, let's talk about e to the x. What's the antiderivative of e to the x? Tell your neighbors, what do you think the antiderivative of e to the x is? Yeah, so some of you might still be in antiderivative mode. Some of you might be in like antiderivative power rule mode, and you might be like adding 1 and multiplying by the reciprocal. Really quickly, like whenever you have like an x as part of your antiderivative that comes like on the outside, think about this. If you took the derivative of this to check your answer, you would have to use the product rule / the quotient rule. Trust me, the derivative of 1 over x plus 1 times e to the x plus 1 is not e to the x, okay? Whenever your antiderivative turns into like a product of x's times other x's, you're definitely going to be wrong. How about that? I won't even say probably wrong. You're wrong, okay? So don't try to do anything crazy and then turn in something into x's times x's. Usually the answer is a little simpler than that. And that's the case here. The derivative of e to the x is e to the x. So the antiderivative of e to the x is e to the x. So don't do anything crazy with the power rule unless you got numbers. And those numbers have to be different than -1. All right, real quick, let's just do a couple. Tell me what f of 1 is over here. And then tell me what f of negative e cubed is over here. Two different questions here. All right, the goal is to try to trick you over here on the left, not with the antiderivative, but with the plugging in 0. How many of you plugged in 0 and thought that e to the 0 is 0? E to the 0 is 1. C is not 3. C is 2. Raise your hand if you made that mistake. It's okay. Don't be shy. Nobody. Liars. So it's e to the x plus 2. I'm plugging in 1. You get e plus 2. This is just like a helpful reminder that in this class, not all answers will be whole numbers. It's okay to get something like e plus 2. Got it? Let's try the other one out. This is a negative first power. You take the antiderivative. You don't use the power rule. C is 1. Plug in negative e cubed. The absolute makes the negative e cubed a positive e cubed. The natural log of e cubed is just 3. 3 plus 1 is 4. Good. Okay. So that covers 1 over x, which we haven't seen until today. All the other ones that you saw in your homework, none of them asked you about 1 over x. So now we got 1 over x, now we got e to the x. Now we're going to do something that is confusing to a lot of students. So, again, like we do with most things in this class, if you figure out the next rule, you're in better shape than if you try to memorize what I tell you. Okay? So, before we try to figure something out, let's just do a quick little review. Do you remember how to take derivatives of change? We're taking derivatives here. This is like, oh, pause on antiderivatives, take a break. Do you remember how to take derivatives of sine 4x? Everybody take the derivative of sine 4x for me. Very good. Some of us, most of us, are using our friends, the O's and the I's. When you have parentheses, we can O and I it. Some of us are past the parentheses part. But who remembers some like key rules, key things to remember when you're taking the derivative of a change? What's a key thing I told you guys? Oh, don't forget this. What starts in the parentheses stays in the parentheses, right? It's like the lacrosse, not the lacrosse locker room, which doesn't exist. It's like the track and field locker room, which you guys never use. It's like the Lake Travis high school house parties. Whatever's happening there, it stays there, right? Not true. You guys just yibber about what happens on the weekend. So we got to work on this, all right? What starts in the parentheses stays in the parentheses. Got it? So you're not taking the derivative of the 4x. It just stays as 4x. For e to the 3x, the derivative is the derivative of e to the parentheses, but what's in the parentheses stays. We kind of just like take the derivative of the e to the parentheses. We worry about the 3 afterwards. What started in the parentheses stays in the parentheses. Okay? Do the last two if you haven't done them yet. What starts in the parentheses stays in the parentheses. Very important. Make sure we do the last two. Make sure we do this last one as well. All right. So derivative of the outside, derivative of the inside, multiply them together, you get that. What starts in the parentheses stays in the parentheses. Derivative of the outside, derivative of the inside. the derivative of log, what did you guys write? 1 over parentheses? I'm going to write it as 1 over parentheses to the first power, just for fun. And then the derivative of 4x minus 2, 4. Okay? I got 1 over 4x minus 2 times 4. Maybe you put the 4 up top. Well, guys, the next set of antiderivatives, we're going back to antiderivatives, deals with undoing the chain rule. I told you there's no antiderivative chain rule because there really isn't. Like, these are for simple chain rules. If we get into more complex chain rules, and I'll show you an example of a more complex chain rule, this doesn't work. But I hope that you guys can figure this out after we took some derivatives, okay? Now, I want you to go back to the first antiderivative you took on day 1. When I asked you to take the antiderivative of x to the 4th. Let's walk through your thought process. What did you do? Many of you understood that you needed an x to the 5th. You started with that, right? But you had no idea what else went along with that. You were like, I need an x to the 5th because that would give me an x to the 4th when I took the derivative. But then you thought about, if you take the derivative of x to the 5th, you don't just get x to the 4th. There's this 5 that comes down. You get 5x to the 4th. So part of your process in figuring things out is you were actively thinking about what happens when you took the derivative. You take the derivative of x to the 5th, you get 5x to the 4th. You weren't all focused on the rule. You like figured out why you needed the 1/5. Okay? Now, I'm asking you to take the antiderivative of cosine 5x. And I'm going to give you a quick hint here, guys. Just like with derivatives, with antiderivatives, what starts in the parentheses needs to stay in the parentheses. It's got to be going both ways. Okay, please try to figure out which function has a derivative cosine 5x. Knowing that what starts in the parentheses stays in the parentheses. Look at that. Now, I'm not giving you a rule. I'm not telling you O and I here. I'm not telling you O and I. Awesome. We're on the next page. We're on the next page. I think it's what I see is correct. What starts in the parentheses stays in the parentheses, Scott. Try to just figure it out. Don't O and I anything. Don't O and I. Don't go O and I here. We're taking antiderivatives. It's completely new. Go. Okay. Ready? Here we go. Here's what I wanted you to do. If you didn't do this, it's okay. We'll eventually figure it out. But you got it. You know you're going to have some parentheses here. You know you have to have the 5x inside there. So many of you probably thought, though you didn't write down, maybe you were thinking, what is the antiderivative of just cosine? Or you were thinking the antiderivative of cosine parentheses. Okay? And many of you are like, well, sine's derivative is cosine. So the antiderivative of cosine parentheses is sine parentheses, maybe plus a c. And you probably put sine plus c. And many of you were like, hey, what starts in the parentheses stays in the parentheses, and you write sine 5x plus c. That's kind of what I wanted you to start with, you know? But then, after thinking, and I'm not going to show like a step for this. This is like a thing that is not shown because I don't want another rule to mess up your understanding of the chain rule. While thinking about taking the derivative of sine 5x, you know that you'd have cosine, stays the same, 5x stays the same, but then times a 5 because you have the derivative on the inside. You don't want the 5 around when you take the derivative of this. When you take the derivative of this, you better just get cosine 5x. So because of this inside derivative, you need a 1/5. And many of you figured that out. Excellent. If you didn't figure it out, hopefully you understand why I did what I did. Okay, let's see. Some of you are 1 for 1. Can you be 2 for 2? Let's change this up. Let's change this to e to the 6x plus 7 for me. E to the 6x plus 7. No. Right. So the derivative of sine is positive cosine, which is what I want. Oh, yeah. Cool. Give it a shot. E to the 6x plus 7. Give it a shot. Maybe instead of thinking power rule, maybe use a set of parentheses. So you're like, oh, that's like e to the parentheses. I might have to redo this homework. Don't like it, all right. Perfect. You guys are just forgetting plus c. That's excellent. You're so close. You see that extra step. What are you doing with your phone? Got through it. You got it. Come on, H. All right, maybe start with this. Maybe you're not sure what to do. Maybe you haven't figured it out. Start with the antiderivative of e to the parentheses, right? Just like the antiderivative of e to the x. E to the x is the antiderivative of e to the x. What's e to the parentheses antiderivative? E to the parentheses. Is everybody following me here? You're taking the antiderivative of the outside first. What starts in the parentheses stays in the parentheses no matter which direction you go. But because of the derivative of the inside is 6, I know I need a 1/6. Okay. Maybe we're 2 for 2, but this next one tricks up a lot of students. Let's see. Who's going to get it right?
Highly doubt it. Except for him. Wait, no, I'm just.
I know it's already wrong. Oh, come on, we got this. Because you're using your phone, that's why. So close. Everybody's taking antiderivative of the inside. Yo, don't take an antiderivative of the inside. What starts on the inside stays on the inside. Think about what you get when you take the derivative of the inside. All right, ready? Here is the procedure. Here's the procedure. Start out by taking the antiderivative of the outside. Everybody, if you don't think you have the right answer, or if you do think you have the right answer, just make sure this is correct. What's the antiderivative of parentheses cubed? Okay? Everybody write that down. Okay? Hopefully you're like 1/4. Great. So, you got a 1/4 and a 4. I don't have anything else besides a plus C. Ready? Here's the last step. What is on the inside stays on the inside. I don't do anything with that. But I think about the derivative of this answer. And when I take the derivative of this, I know I'm going to have the derivative of the 3x plus 2, which would give me a 3, which I don't want that 3. I need to get rid of the 3. So the last step is to undo the derivative of the inside. I'm not writing this down. I'm not writing an O and an I for this. I need you guys to just know why you need a 1/3 and a 1/4. The 1/4 comes from the 4. The 1/3 comes from the 3x plus 2. Okay? Giving us 1/12. 3x plus 2 to the 4th plus 2. The answer was both. All right, so here's your simple undoing of the chain rule when you're anti-deriving. Start by anti-deriving the outside. The antiderivative of regular f parentheses is big F parentheses. This is step 1. Step 2, your inside stays on the inside. What starts in the parentheses stays in the parentheses. For derivatives and antiderivatives, it has to be like that. But because of the derivative of the inside, you get 1/x. Okay, let's do one just like the last one, not the one on the left. Let's do this one on the right. Everybody, try the one on the right. Do the one on the right. Start with the antiderivative of the outside. Oh, good. Do the other one. Because I'm going to change the one on the left to really screw you. To really mess with your brains, I'm going to do the one on the left. Wait. No, wrong. Wrong. I know. Yeah, good. Wait. No. Come on. You didn't. No, you're not. This one. The one with the star next to it. Wait. Yes. Look at the one.
Bro, I'm so confused.
You.
The 4 does the 1/4.
No. No, wait. Whoa. Hold on. What's the antiderivative of parentheses in the 4? 5. You put a 3.
No, I know. I messed up there, but I'm still saying it would be 1/4.
No, start over. You just need to start over. No, you need to start over. Okay, don't do the one on the left, guys, because I'm going to blow your minds in a second. Ready? Here we go. If you didn't even try, you need to have parentheses fourth. Parentheses fourth. That's what you start with. You then have parentheses to the fifth, 1/5 plus C. You then fill in the inside and understand the derivative of the inside involves a -3, which is why you need a -1/3. The -1/3 comes from undoing the derivative of the inside. The 5 comes from, the 1/5 comes from undoing this 5 when it comes down. This is antiderivative. All right, ready? I'm going to really screw you guys up. Put a square right here. Make it sign 6x squared plus 7. Make it sign 6x squared plus 7. All right. Okay. You are all doing the right thing based on what you think is right. But you're all getting the wrong answer. Not because you're not doing it correctly. It's because you don't understand how going backwards is tricky. You guys saw this on your quiz today, right? X squared plus 2 squared. What did you guys do? You FOILed it, right? I hope you did. And when you FOILed it, you got x to the 4th plus 4x squared plus 4. And then you got 1/5 x to the 5th plus 4/3 x cubed plus 4x plus c. Hopefully you did that on your quiz today. If you didn't, sorry. Now, pause. I'm just going to show you something. Let's pretend we didn't FOIL and that we used the technique we just learned on this. Ready? You would have put parentheses cubed times a third. You would have put x squared plus 2. And then you would have put a 1/2x. This is what everybody's doing. They're like, oh, I need a 1/2x. Guys, I guarantee you, if you multiply this out, you don't get that. This is wrong. This is correct. You might be thinking 1/12x with the negative cosine 6x squared plus 7 plus c. I'm sorry, you're wrong. Nobody knows how to take this antiderivative. So you're probably like, well, Mr. Messner, what the hell? Were all the ones wrong? Like, what is going on? No, I'm teaching you a valuable lesson here. It only works when x to the first power is on the inside. This does not work if inside parentheses there's any other power of x. Think about it. Did you write negative 1/12x times cos 6x squared plus 7? You guys wrote that, right? Take the derivative of negative 1/12x times cos 6x squared plus 7. And then you're like, oh, no big deal. It's an O and an I. No, it's not. This is a product of x's and x's. And when you take that derivative using the product rule, it's going to get real gross. And it's not going to simplify to be sine x 6x squared plus 7. Okay? On your test, and I'm going to give you this really quickly. You will have this question. I don't think it's the exact question, but you'll get my drift. On your test, this will be a question. One of your answer choices will be 1 over 2x, x squared plus 2 cubed, or it'll be 1 over 6x, x squared plus 2 cubed, plus c. Yo, not correct. Okay? The actual answer will be distributing this, getting x to the fourth, antiderivating 1/5 x to the fifth. Like, you might think, oh, I can undo this using kind of the Mr. Messner undoing of the chain rule, but it only works when this is x to the first power. So don't select that. Okay. Let's do some more ones that are obtainable because it's just x to the first power. X to the first power. Do this one on the right first, please. Do the one on the right first, please. Do the one on the right first, please. Scott, you're killing me. You're killing me, Scott. Killing me, Scott. Good. It's e to the parentheses. I just woke Alfred up. That's great. The antiderivative of e to the parentheses is e to the parentheses plus c. So the antiderivative of this is e to the negative 2x plus 3, but I need a negative 1/2. The negative 1/2 comes from the derivative of negative 2x plus 3. Everybody, do this one now. We're going to get a little trickier and trickier. 1 over 4x minus 2 cubed. No. Step 1 would be to write it as 1 over parentheses cubed. Now, if this was 1 over x cubed, how do you take the antiderivative of a power? You move it up. Hopefully, your step 1 was to not do anything crazy like use a logarithm. So everybody's going to make that mistake at some point. Hopefully, your first effort is, oh, that's just a negative third power. The power rule works for every power except just negative 1, so the power rule can be used for the negative third power. Go ahead.
Why can't we use the logarithm?
Because the power rule works for every power, and it has to be used for every power, except the power rule can't be used for a negative first power. It's not.
No, it's not that. How'd you get 12? From the 4. Oh.
Ready? The antiderivative of the negative third power is a negative second power with a negative 1/2. The inside is 4x minus 2. The inside derivative is 4, which is why I need a 1/4, giving me my final answer, negative 1/8 times 4x minus 2 to the negative second. or negative 1 over 8 times 4x minus 2 squared plus a c if you get rid of the negative exponent. Let's make it a little trickier. 1 over 3x minus 2. 1 over 3x minus 2. 1 over 3x minus 2. Did you ask Mathways to take the antiderivative of sine 6x squared plus 1? No. This can be done. That can't be.
Yeah.
Not like that.
Yeah.
Ask Mathways could probably take derivatives. Why don't you just ask it to take the antiderivative?
Well, I didn't want that.
I mean, it's okay. Do it. It's fine. Fun. I use Wolfram all the time to be like, I used it when I did my college homework. And I had to do all the steps. It just gave me the antiderivative. Nice. Rick's has got you. Lost. Yeah, well, good. Now, remember when I said the derivative of log parentheses was 1 over parentheses to the first? There we go. There is a composition here. The composition is 1 over parentheses to the first, which is our negative first power. Now, we can't use the power rule because the power rule works for every power except negative 1. I have to use the power rule for all those powers. For this one, we need to remember, the antiderivative of a negative first power is log absolute parentheses. What starts in the parentheses stays in the parentheses. Because of the derivative of the inside, you know you need a 1/3. Do the next one. Really the same deal. Cool. Oh yeah, we're observing a lot.
I'm not really slow. I was doing it on my phone.
I know.
So you know how slow I am.
No, I don't. I do not know that. I don't think that's true.
It is.
You crushed your quiz today. You weren't the last one to finish your quiz.
I know, but I usually am.
Not true. You did a good job. You got it right. So you can't do that. That's not cool, man. I stay off social media, bro.
Look good in that.
I stay off social media. I stay off social media. All right, so we get log absolute. What starts in the parentheses stays in the parentheses. And then we have the negative 1/4. Great. All right, now they get even trickier. Let's go to these bottom two, the e to the x's. Okay, skip the 2 to the x. We'll come back to that. These are two extremely important ones. After everything that we just did, you might be feeling kind of confident. We get to this one. Let's see how you handle it. Make mistakes, get the wrong answer. Now's the time to do it. Don't wait until later to get the wrong answer. Make mistakes, have to try, don't wait to get the wrong answer.
Oh, yeah. Derivative of that, too.
Yes, Panini wins.
Oh.
No, he did. I mean, he had the key. It's right where I want you to be. Is the derivative of x? What's the derivative of x? What's the derivative of x? 1. Is that 1? No, it's definitely is. Okay. You might be like, oh, is there something crazy going on? No. So, good try. All right, ready? We just did a couple where we saw a negative first power, and many of us are like, oh, negative first power, right? Not really. It's not a negative first power. It's a negative x power. So if you said, oh, it's a negative first power, it's like, no, not really. What is the power? It's negative x. So actually step 1 is to rewrite it as a negative x power. And then to be like, oh, that's just e to the parentheses. Oh, I don't need to use anything crazy because it's just e to the parentheses. See if you can all figure out this one now. Turns out negative e to the negative x. This is actually the correct derivative and antiderivative for 1 over e to the x. It's the same. Okay, do the next one. This is not a negative first power. This is a negative 2x power. So if I were to do this, it'd be the antiderivative of e to the parentheses. Antiderivative of e to the parentheses is e to the parentheses. What's inside the parentheses? Negative 2x. Negative 2x, I need a negative 1/2. All right, you will see this on your test. Let's go up to the previous problem. Go back. We're not going to do the differential equations. There's not really. You'll do them on your homework. Ready? Last thing, and then you guys can like start packing up. But wait until we're done. Okay. Last thing. You all forgot the derivative of 2 to the x. It's 2 to the x times the natural log of 2. Natural log of 2 is a number. Okay? The antiderivative of 2 to the x involves 2 to the x. But it can't be just 2 to the x, because 2 to the x's derivative is 2 to the x times the natural log of 2. I don't want 2 to the x times the natural log of 2. I just want 2 to the x when I take this derivative. So who can figure out what else I need? Dylan Clark White strikes again. 1 over ln2 times 2 to the x plus C is correct. Bam, boom. That's what I'm looking for. You guys are a lot better than the other classes at getting that. Excellent job.